All right, for the third and last example, I want to try something like this. You're going to push a box across the floor, one of these deals. And you start pushing with no force. So you're just going to slowly increase how much force you put on it. And then after 30 seconds, you're going to get to pushing as hard as you can. So I'm going to look at how much force you apply as a function of time. Okay. And so you're going to keep on pushing until you get to 30 seconds. And then it'll flatten out. After 15 seconds, right about here, the box will start moving. So down here, you've got the box staying put. You haven't pushed enough. It's like pushing your refrigerator, pushing your wall. It doesn't matter. It's not moving. Then over in here, it starts accelerating. At this point here, your force maxes out. And then what happens? It keeps accelerating until you reach 45 seconds right here. Right, so this is 45 seconds. At that point, the velocity is constant. So we want to figure out how many different phases are there in this motion. How many different places are the physics different? Okay. So we know there are 3 transitions for the way things are working. So let's put these together. So the push, like I said, starts at 0 and then goes to its maximum here at 30 seconds. Right? And then it's flat. Okay. So it starts off, there's no speed, right? It's not moving. It starts accelerating, comes up here, and then it keeps accelerating after your maximum speed, after you've got the maximum force on it. Now that means it's going to accelerate less, so the speed's going to increase less until you get to the point where it stops accelerating like that. So you can see that the motion is a little bit different. Now this is simplified. It'd be more curvy than this, but basically flat, increasing less, and flat again. So basically we have 1, 2, 3, 4 phases of motion, right? The first one is your push doesn't move the box. The second one is push increasing. Box is moving, accelerating. 3 is the push is constant. The box is accelerating. Moving, accelerating. And the fourth one is the push is constant. So is the speed. Okay, so we've got those 4 spots there. So we want to figure out then where the forces balance. Well, what do we know about this? If something's not moving, then the forces on the object are 0, so they balance. So they balance here. Off the screen again. And when you're going at its constant speed, the forces balance. So they balance here. No force, no net force. All right. Here and here, in both cases, you you've got some sort of acceleration, right? So the net force here is increasing. The net force here is actually constant, right? And so basically, no, that's not really true. Probably it comes down like this. But got the force here in there. But this is all positive, so this is not balanced in this region. So before this thing starts moving and after it reaches its maximum speed, the forces are balanced. Check, check. And then here, where the object accelerates, they don't balance. And that's Newton's first law. That is the law of acceleration, or law of inertia. Okay, so that's just a qualitative thing that we can do with these graphs, right? So that's the third problem. That's the third example. I'll come back next week with the law of acceleration and the law of reaction. Well, basically I'll talk about collisions instead of the law of reaction. We'll talk about the law of reaction, but that'll be mostly important for collisions. Those are the other two of Newton's laws. And then we'll do one more thing, and I guess we'll have to get ready for a test after that, a quick test. So that is everything we have for the first lecture on Newton's first law.